Okay, now let's quickly run through a short session of Euclidean here. Remember, we spoke about the proofs. We tried to remind ourselves of the proof the last time, and we started dealing with some questions. Showed you that it is important to get this particular marks. These marks are marks that will boost your paper too. Before we start getting to heavy stuff, which we are going to do today, all of this should be well taken care of. Remember the principle we're using? Find the source of the angle, describe the nature of the lines around the angle. It helps you to find your angle quickly. So if you use that method, practice with that method, save time using that method, and get all your marks. We did all of this, and we said for you to prove proportionality, similarity, you only need to prove what? Angle, angle, angle. And that is a common trend in our paper too. We did this proof last week as well, saying this is one of the 6 that you must know. I'll see if I can do the second one. Okay, I'm here now, and this is proportionality. Let's quickly say something here before I go into question. When it comes to proportionality, all right, proportionality theorem. The basic thing that you need to learn quickly is, when do we use proportionality theorem? When you have a triangle and what? 2 parallel lines. Automatically, you should know that proportionality then plays a big role. So you have that, and then you have a parallel line. Once you see that, you should automatically bring in your proportionality theorem. And what's your proportionality here? AB depending over AC. So I've taken the top over the whole length. What will this one be? AD over what? Over AE. What will be your reason? Prop what? Theorem. And you know that what? BD is perpendicular to parallel to CE. Just one thing here, and I'll go to questions now. If the examiner wants to deal with the base, when dealing with the base of the triangles, when dealing with the base, the bases, prove similarity. If I want to include the bases here, I've got to prove what? Similarity. If I need to use the base, and you know that this angle here would be equal to that angle, reason would be corresponding. This angle here would be equal to that angle as well. So these 2 angles are equal. Those 2 are equal based on what? Corresponding angles. Corresponding angles. Once you are able to, so anytime the examiner is requesting for the base, you have to deal with similarity. And you would see here now that ABD is similar to triangle ACE. ABD is similar to triangle ACE. Once I write my ratios, what would I have? AB over AC is equal to what? AD over AE is equal to BD. I don't know if you see the superiority of similarity over proportionality. Check this. I want you to see something here. Do you see this here? I don't know if you see it on top there already. AB over AC, AD over AE. So that shows Who's the power that your similarity has? I don't know if it makes sense. Your similarity is just saying AD, AB over AC, which is here. AG over what? AE. But now, because I prove similarity, check what happens. BD over what? And that is BD over, I have included the base. Your similarity was just working on the sides. But for me to include the base, what do I need to do? Prove that these angles are what? Triangles are similar. And I remember similarity, we spoke about it. All you need to do is to prove what? Two angles. The proof for similarity is angle, angle, angle. I want us to play around a few questions, just two or three. Okay? But please, the first part we did last week, I don't want you to mess those things up. Start practicing them. Describe the nature of the lines around the angle, trace the source of the angle. Those ones I've called them mark boosters. Question 8 and part of question 9. 3 angles equal to x. All of those. And after that, similarity. We need to get all of those. Prove that 2 angles are similar. So, as we practice, you will see the trend in these things and begin to understand the simplicity based on repetition. They'll keep repeating the concept over and over again. So, the questions I'm going to look at are from last week as well that we didn't finish. But I want it to be as simple as what we did last week. Simplify it. I really enjoyed last week's session. All right. So it makes it solid when we understand. I'm just going to run through. Look at that. In triangle ABC, AQ ratio QC is 1 to 3. AQ to QC. All right. I don't know if you have found AQ to QC. AQ to QC there. So this is 1 to 3. We can say 1K, 3K ratios. All right, AP is parallel to QS, okay, with P and S on BC and Q on AC. The diagram is very clear. Now, I want us to learn how to interpret this thing here. It says BC equals to 1 over 3. BP equals to 1 over 3 what? BC. When you see that, move the numbers to one side. Move the letters to one side. Check what I'm going to do. BP is equal to 1 over 3 what? BC. You know what I'm going to do? Divide both sides by BC. Get rid of the letter here. What do you have? BP over BC equals to what? 1 over 3. So BP and PC, we can use a different letter. BP is 1x, and my BC is what? Do you see that? What is that? 3x. So that's the first thing that we needed to sort out. Now we know that there are triangles and there are proportionalities that we are going to work around. Let's go check what the first question says. The first question says we should find what? BP over PS. Interesting, 5 marks. Let's trace those lines. Let me duplicate this quickly. Let's trace those lines. It will help us to trace them. I'm going to use color codes to trace the lines out for you. So I will see which triangle we're working with. What are we looking for? BP over what? PS. Okay, I hope that makes sense. Now, do we have a triangle that has these two involved with parallel lines? I don't know. Let's check. I don't know if you see anybody seen a triangle. What we're looking for is triangles. Okay, so let's try. All right, I see a triangle here. Parallel lines. That's what I'm looking for. Those are the kind of things that you are aiming to get. Okay? But what I now notice is I've got a problem. I don't have any information here. Do you see that? Yes, I'm looking for this. It would have been easy if I had this information, because that is in a triangle with two parallel what? Lines. Let's check. Is there another triangle with two parallel lines? Let's see something. All right. I see this. I don't know if we all see that. Okay, with that, that can actually help me to get PS. Why? I know this full side. Oh, by the way, check something. I don't know if you see this, that if this whole thing is 3x, this whole length is going to be what? 2x. I don't know if, are we together there? See, you're just going to walk around. What is it that I can get? All right. So, I am now working with which triangle? This triangle, right? Does that make sense to us? That's the triangle I'm working with. What can you write? What ratio can we write? PS is what is missing. Are we together? PS is what is missing. Interesting. What can we then do? We're looking for PS. Can I say PS? That's what I don't know. All right. PS over. Okay, sorry, I'm just getting your message now. PS over, if you like, SC. Because we do know SC. So, PS, SC would be equal to what? Okay, let's consider triangle. Consider triangle what? APC is what we all fall there. So, PS, the first part, over SC, the remaining part. What do you think it will be equal to on the other side? Guys, you look lost. This side over this side, you are looking at this triangle. So this side over this side, you repeat that same pattern on the other side. What am I going to have? AQ over what? Over QC. If I say PS over PC, repeat the same pattern. AQ over what? AC. Just repeat the same pattern and see where it leads you. So here this time around I'm saying PS over what? SC should be equal to what? AQ over what? QC. Right, let's see. Oh no, let's use white. What is it equal to again? AQ over QC. What's your reason? Prop what? Theorem. And when you write prop theorem, you must tell us the lines that are what? Parallel. Which lines are parallel? E. Parallel to what? Let's throw in all the values that we know. PS over PC. No, it would not be wrong. All right, Mary. You'd see, I'm going to use it as well. Let's see where this one will lead us to. Do I know PS? No. Do I know SC? SC. Oh, we don't know SC. Oh, you know, okay, the way I wrote this 2x, that's, I was thinking, okay, sorry, let me write this 2x nicely. Since we don't know SC, this would take us a long way. Okay, we know PC though, right? PC is what? 2x. Okay, it's, Mary, I get you now. It's going to be easier to walk around PS. PS and what? PC. What we know. I was thinking PSC was the 2x. All right, so PS over what? PC. What will it be equal to? AQ over AC. We're saying the short over the whole, the short one over the whole thing. All right. Do I know my PC? 2x. Do I know AQ? 1k. Do I know my AC? 4k. Can we just now deal with the k cancels out, right? PS over 2x. I want to write it out first. Depending on you, what do you want us to do? Cross multiply or what? Okay, let's cross multiply. But we are looking for comfort right now. So what is PS? 2x over what? 4. And what is that? 1 over 2 what? X. So already I got my PC. My what? PS. Yes? Yes. You have to put the x because it's a ratio. It's not the length. So what do we have here? 1 over 2 what? X. What are we looking for? BP over what? PS. Do you see I have the two ratios now? So what is my BP over PS? What is BP? 1x over what? What is PS? Half what? X. BP. What do you mean? Okay, so what is 1 divided by half? 2. Determine with reasons the following, and we are done now. Our answer is check the 5 marks. It's not heavy at all. Just playing around with your parallel lines and just knowing proportionality. It's quite sweet to just go through. What do you think the next one would be? BR over what? RQ. BR over what? RQ. Okay, let's finish before you take a picture. BR over RQ. Look, study the lines first. Once you study the lines, life is going to be very easy for you. What are we looking for? BR RQ. Do you see it's the other side of this triangle? And by the way, so right now I am focusing on this triangle. Why? I'm looking for BR, RQ. But I know BP and PS. So how do I then, what do I write? BR over RQ should be equal to what? Remember, I'm moving top over bottom. I must do the same on the other side. Top over what? Bottom. BP over what? PS. What's my reason? Prop what? Theorem. Which lines are parallel? RP parallel to what? QS. So therefore, BR over what? RQ. By the way, do you notice this is the answer I got from here? This question is this. What is our answer? 2. We're done. 2 marks. Type your questions and if you are okay, let me know. Um, 8.2.1, 1 over half. If you write 1 over half x, you lose 1 mark. You need to simplify. 1 divided by half is 2. So in math, we always simplify our answers. Let me see. Okay, we okay? So, Bibi? Once you bring in that, I'm going to assume that already things are wrong. Guys, so what have we learned? Use the answers to guide yourself. Once you see a question with parallel lines, you are bringing proportionality. The way you move on one side is the way you move on the other side. Use what you have to get what you want. We're going to try, I think, all the questions. Yes, look at this one. In the diagram, two circles PSL and PQR touch internally at P. K and L are the centers, and PQ is the diameter. Check. PQ is the what? Diameter. Already, this is Euclidean. Start thinking. PQ is the diameter. What's going on through your head? Equal to 90. What equal to 90, baby? You can't just say equal to 90. Angle what? R. Angle in a semicircle. Look, the theorem is just by default. It's in your head. Diameter. Already I know this is what? 90 degrees. The whole angle there. By the way, do you notice that is the center here? It means PL is also what? A diameter. It means angle S is also what? 90. Does that make sense? Are you aware that this is equal to that and is equal to that? Radius. I'm just checking. The examiner has told me a diameter, so I'm just playing around with everything I know. PK is a radius. KL is a radius. KS is another radius. Are we together? Check this. Let me do something here. Do you know this diameter here, which is the radius of the big circle? This is also a radius. By the way, this is also a radius. From the center to the... So those are the things my eyes are just quickly catching very fast. I don't know what the examiner is going to ask, but already I'm seeing a lot of things there. This line is actually parallel to that line. Do you know why? This angle is 90, and that is 90. Corresponding angles. It means that's converse now. Those lines are... I want you to see what this diagram is loaded with information. We're not even going to the question. We're just playing around with the diagram. I'm going to clean this again and go through from the beginning. We are told that PQ is a diameter. Immediately I hear the word diameter, you know what comes to my mind, right? P angle R equals to what? 90. But if I check, PL is also a diameter because it passes through the center. It means angle S is also equal to 90. Remember your fun angles. So do we all see the F though? Do we agree? That's the F there. Which makes this line parallel. What's the reason? Converse of corresponding angles. I'm checking my radius quickly. That's a radius. That's a radius. That's a radius. Can I call this 2R? Can I call this 2R? Because from here to here is 2R, which is the radius of the big circle. And I also see that this examiner is going to work around proportionality. Do you see a triangle here? So I'm already preparing myself for the question. I don't know if you see a triangle here with two parallel lines. Do you see that? And I can also see a triangle here, another proportionality. We're preparing. We don't know what this examiner is going to give us. Since we said this line and this line are parallel, do you see another triangle here? of proportionality? Remember, when do you use proportionality? When you have a triangle and you have what? Parallel lines. Those are all the things I quickly picked up. And that's how you need to think. Let's go check what this examiner is all about. Determine the size of what? PSL. Oh, this angle. What's your answer? We are done. 90 degrees. What's your reason? PSL equals to what? 90 degrees. Angle in a semicircle. Prove that SL is parallel to RQ. Let's go check. Where's my SL? How did we prove those lines? And if should you have not even found that that's 90, if they said parallel, you are already thinking about what? Fun. So you are looking at angles that are what? Equal to each other. Whether via F, whether U or N. But we could not say that is 90 or parallel until we mentioned that R is also equal to 90. Right? R must first be equal to 90 before you can say these two lines are parallel. So I'm going to come here and say angle R equals to what? 90. What's the reason again? Angle in a semicircle. Now you're going to get 1 mark for all of that. Why? You've already used that statement. That's proof reason up there. Now can we say that SL therefore will be parallel to what? RQ. What is that? Converse of what? Corresponding. When do you use converse? When you use angle to find the line. If they gave me the line, I would have said those angles are equal, corresponding angles, right? But now I use the angles to find the line. It's converse. So make a note of that. Converse, when you use the angles to describe the nature of a line. When you use the angles to describe the nature of the line. Please make sure you write that down. Right now you should have a book preparing for study. Converse, corresponding angles. When do you use converse? When you use the angles to describe the nature of a line. All right. Let's go see. 3 marks. 2KS is equal to LR. 2KS equal to LR. Let's see. 2KS. If you are actually checking, do you notice? I don't know if you see that I'm done. KS is equal to LR. If you check, you will see that I'm done. Check your KS. What's your KS? R. What's your LR? I'm done. All right. So what do we know? Let's write that down. Let me see quickly. Let's write that down. So we can say KS. Okay, just so we are on the same page. Or let me do it here. We want to prove that 2 what? Let me get the question again. What are we proving? 2KS is equal to LR. I want to keep the diagram. 2KS is equal to LR. What do we know? What would we write? KS is a radius, right? Are we finding that? KS is radius. That's given. Let's write all the reasons so that we don't lose marks. Given. What can you tell me? PL is the diameter. Does that make sense to you? I cannot jump to LR immediately. PL is the diameter of the smaller circle. All right, so can I say PL is equal to what? 2KS, which is what? Diameter. But as well, I now know that but PL equals to what? LR, which is what? Radii. Does that make sense to you? Of the big circle now. Therefore, PL is 2KS. 2KS equals to what? Because I'm only replacing that there. So it's important. And look, I always say, don't let the diagram intimidate you. It will definitely do that. Trust me. Checking the diagram, go like, okay, this is my varsity walking away from me right now. The diagram will always intimidate you. You need to just, what is it that I can do? What is it that I see? The diagram would come and want to just attack your confidence. That this is UJ walking away from me. This is UCT walking away from. But now tell them to come back. You are following. By gradually. And that's why I'm saying your 10 minutes reading time, make use of it very well. Don't be praying in that 10 minutes. Or putting your head on the table. Or, no. You're saving time by quickly attacking your Euclidean geometry. Remember, you cannot touch your calculator. If you could use your calculator, you know what I'll tell you to do? Do stats. But you cannot touch your calculator, right? You can only stare at the book. Why not stare at those angles? Make sense? And start saying, okay, that is equal to that. Okay. That. All right. And you can use your hand, remember? Yeah. How are you going to turn the book? Are you going to blow it? No. You can. You are going to touch, you are allowed to touch the paper because that's how you are checking. So instead of flipping all the pages, just go to question 8 quickly. List what is the angle equal to N2. What are you seeing? Oh, that's a radius, diameter. Answer it in your head. You have the reason. That. You'll be surprised that you can finish in before 10 minutes. You go to the next one. If there's a proof, try to remember the proof. Okay, which proof? How do I get this proof? It's in your head. You are waiting for, you may now start. You see, when they say you may now start, you are downloading. When people are still looking for angles, you are already moving to the next question. You are saving time. Important stuff. Okay. Leslie, are you okay now? She sent me this question today. Guess she was panicking. All right, let's see. Let me get rid of these pages. What are we looking for? Oh, we're done with this one, right? We're done with that one. Determine the value of what? KL over PQ. Let's go to the diagram. KL over PQ. Now, it's amazing that there are no numbers here, but they want values. KL over what? PQ. Let's go check. KL radius over. If you follow what I've done, I don't know if you see that I'm already done as well. KL is radius. PQ 4R. Baby, did you see my 4R? And I'm done. KL is R. PQ is what? It's R. Or RR to R. So we are done there. 4 marks. KL over what? PQ. That's what we are looking for now. So we know KL is what? Radius. Is that fine? Let's write it because we don't know what the examiner wants to mark. So KL is equal to what? Radius. Now what is PQ? PQ is what? Can I say PQ is 2PL? Because you need to link your answer as well. I don't know if you agree. Remember, PL is a diameter. LQ is also what? Sorry, PL is a radius of the big circle. LQ is also what? Radius. So we are saying, let me write it out for you very well to see. We're saying that PL is equal to what? LQ. Therefore, PQ is equal to what? 2PL. Does that make sense? We're good. Okay, if that's the case, so, and this is going to be, did we do something earlier on? We got, I want to use what we got earlier on. We got LR, where am I seeing? I wrote, okay, we got PL, right? PL equals to what? 2KS. Make sense? So what do I have? What's my PL? 2KS. Can I say KL equals to KS? Radii. I'll show you where I'm writing KS. So KL, presentation also matters. What is my KL? KS. What is my PQ? 4KS. What's my answer? Do you see the link? I just wrote both KL and PQ in terms of the same value. Okay. Are we together? 1/4. Check your 2 marks there. Easy 2 marks. It looks hectic. The diagram looks scary. But we are almost done. Are we okay? So just take it one step after the other. Don't allow yourself to be overwhelmed or intimidated. Once you start panicking, you start seeing flames. You won't even see lines. You'd see waves. And these are all straight lines. So we're going to get to a point where we don't panic. We're just going to say, okay, what is it that we can see? Let's walk through gradually, and we are done. Let me see the last question quickly. 3 marks. Take a picture. Okay. It is given that PQ is 30 units. Let me do this. Let's work on a new page. PQ is 30 units. Okay. Let me write that information here. I just want to clear all of this. We know that PQ is 30 units. Let's see. PQ. Where's my PQ? All right. This whole thing is what? 30 units, right? What are we looking for? No, where's my question now? Where is it going? Qn over nr equals to what? 7/9. Qn over nr equal. Let me quickly fix that. It's a ratio. Qn over what? nr. So can I say 7k? nr is what? 9k. Do we agree? All right. What are we looking for? The length of Lm. Let's see. We're looking for. This is baby nets now. Do you notice my red triangle? That's where the examiner is also focusing on. All right. Let me show you again. Highlight it. So I can work with this. Can I work with that? By the way, if this is 30, what is this length? 15. Make sense? Do we agree? Okay. Now, this is why it's important that whatever you find, put it on the diagram. It makes your life easy. This is 15. And please, don't say it's divided by 2. Already you are creating problems. Can we use proportionality since I'm looking for LM? When do you use proportionality? When you have a triangle and 2 parallel what? Lines. Okay. I don't know how you want us to work it out, but we can. Since I am looking for LM, I can actually work it out straight. Let me draw the triangle for you. I want you to see something here. There are 2 ways to do this, but I want us to just go straight into it. This is what we have. And I've got a parallel line there. What is this? R, N, Q, L, M, and Q. I know the whole of this length as what? 15. I know this as what? 9K, 7K. I don't want you to do too many things, and I'm looking for that. What do you know? I am looking for LM, but I know the whole length. Can we walk around that? I'm looking for what? LM, but I know the whole length. So can I write LQ? What will that be on this side? It is this top part over total. What will this be? Top part, Rn, over what? RQ. Same pattern. What do I write? Prop what? Theorem. Which lines are parallel? LR parallel to what? NM. I'm looking for LM, right? But do I know LQ? 15. It's not a ratio. We are told that's the length. What about RN? It's a ratio. 9K. What about RQ? 16K. Do you see we're done already? What is LM? Cross multiply. 9 times 15 over what? Over 16. You get your answer. Is that here? It is not. Okay, so I'm saying, why is it 9K, not 9? Check. The examiner, every time they give you a ratio, let me go back to the question. Do you see, they said it's 7 over 9. For all I know, check this. This could have been this. 14 over 18. That could be the real length. Do you know if you divide both by 2, what are you going to get? So it's a ratio. That's why we always put what? K and K. The one that is not a ratio is this they've given you. But once you see it like this, it is a ratio. So it's not 7 units, it's not 9 units. It is 7K over what? 9K, because it's a ratio of the length. All right, got it? What's your answer here? Fraction. 1. Units. Use fractions. 135 over 16. Guys, I don't know if I tried to make it look doable and easy. Nothing scary as it was before. Just learn the approach. It's not like you're going to do this question, the same question. Learn the approach. Look at the question. Check what you have. Do you have parallel lines? Do you need proportionality? If you have to work with the base, what do? Prove similarity. Runga, you okay? Which one? Okay, we're going to play with one more question and then we hit paper 1 quickly and start reminding ourselves. I know some of us now, we are focused on paper 2. Paper 2, we are beginning to get how to solve for X. kind of, but go back to inequalities, go back to simultaneous equation, go back to all of those. All right, let's quickly look at, I think we have one more. But so far, I just wanted to appreciate the simplicity of the approach. And that can only become better. Just take one question and keep practicing. All right? There's a lot to do. Look at this. All right. Look, the diagram looks scary as well. But I want us to see. In the figure, AC is a diameter. I am going to stop immediately. What can you tell me? Which angle? You're just telling me angle. Angle? Okay. That mistake is costly, Biggie. 90 degrees. CG bisects ACB. Bisect means divide into what? 2. CG. Where's CG? Bisect what? ACB. Okay. CG bisects ACB. Can we call this X? And this also will be X. Because they said, I don't know if, are we together? CG, this CG bisects the two lines. All right? Okay, let's see. What else do we have? GF is perpendicular. Okay, that's fine. GF is perpendicular to AC with F on AC. And they said AD is parallel to what? GC. Do you see a triangle there as well immediately before I even start? Look at your parallel lines. Look at your parallel lines. So those are the things I'm looking at. Already I see a parallel line and I see a triangle. I know that this examiner is going to give me proportionality somewhere. Take note of all the information. All right, let's quickly run through. 18 marks here. Prove that CAD, triangle CAD, is an isosceles. What is an isosceles triangle? Either two angles are equal or two sides are equal. Let's go and check. I want you to try for me. CAD. Can we prove? How many marks is this? 4. All right. Let's all think. CAD. You know the rule of isosceles, right? Which angles can we prove? Which angles? Okay, we have XX there. Walk around those quickly for me. There's no tangent here, so don't tell me about 10 chord. Four. D. Which angle are you referring to? Angle C. So what will that angle be? All right. Biggie has just opened up, broken the ice. We'll see where we are going. 180 minus 2x. Okay. Anybody? Those of you at home as well. C equals to 2x. Test me out. What do you mean C equals to 2x? You mean 180 minus 2x? Okay, this C is 2x, x plus x, 2x, okay? What else? Yep. Yeah? What's your reason for saying angle D equals to x? What's your reason? Sorry? There? Okay, look. We know this and this will be 2x though. But how do you know it's x and x? That's my... Yes. Angles in a triangle. Yeah. Okay. Baby, you've answered me that we cannot assume that they are equal. No, it's just... What if this is 1.5 x and this is half x? Do you know it's possible? No, we're not complicating. You need to give the correct reason. So you cannot say that. Because of co-exterior. What do you mean by co-exterior? Yeah? D equals to y. Corresponding angles. Now, that's very good. Bibi, stop making assumptions. We don't make... So, look, your aim, I told you that. Let me show you something before you... I said, we know that if we can get this angle and this angle, will be fine. You're not applying the principle I taught you. That's what I'm saying. I am looking for this angle, right? Yeah. Describe the nature of the lines around the angle. Do you see that this is the second parallel line? If you learn to do that, you would see that all of these questions are... Let me use a red one. All of these questions are not difficult. So I'm looking at that first line. Check the second line. Do you notice now that I've got my F? Okay, let's sort this one first. So this is what? This one is X. What's your reason? Corresponding angles, right? If this one is X, automatically now we can say this is X. Why? X plus X would give us what? 2X. Or sum of angles in a triangle. Check it. A plus D plus C equals to what? Maybe I'll come to your method just now. X plus D plus 180 minus 2X equals to what? 180. We're looking for D, right? This 180 goes over there. Make sense? X minus 2X. It's negative X. When it goes over to the other side, so that is X now. Right? Okay. That was working with D. Bibi? Now, if you want to work with A, because either you look for D or you look for what? A. Let's go work with A quickly. I want you to see that those two things I gave you are magical. Come work with A with me here. Again, do you see it's connected to what? A parallel line. I'm thinking about what? Fun angles. So do you see that I've got my answer? I don't know if you all see, guys, if you all see the alternate angles already. X, X. So automatically this is now what? I don't know if you just enjoy the beauty of just playing around with those things. With those two principles that we gave. Nature of the lines, source of the angle. It keeps working and showing us that maths can be done with ease. So the first thing we did was we defined what an isosceles what? Triangle is. We know that we need to have two sides equal or two what? Angles. Okay, I want us to write our answers down. So we didn't even need the 180 minus 2x at the end of the day. No, it's a guide. No, you're making that same mistake again. That you have this as 180 minus 2x doesn't make this x, doesn't make that x. Okay, now if you are talking that, okay, this is x, then we can use this one to get this one as what? X. All right, I just want us to write the correct principles and not say, okay, it looks like it's an assumption. It's no. Maths and assumptions are never in the same positive statement. Okay, let's write our answer. What are we going to say? I think we can go both ways instead of start. Can we just say angle D equals to angle? Okay, I would say let in your when you every question has a diagram. You are allowed to label all of this. And when you label, so this is my answer sheet. This diagram is going to be there. Label it as X. Is that okay? You are allowed to do that. So I would say let GCB be equal to what? X. Make sense? Or even you can go to your page and write C1, C2. You are allowed to do that. As long as you write it in the answer sheet as well. There's a diagram before all the answer sheets. Write it there. So we know that C1 equals to what? C2. That one is given. Let's say it's equal to what? X. Can I then say angle D equals to angle X, which is C2? Why? Corresponding what? Angles. Which lines are parallel? AD parallel to GC. Make sense? What else? Angle A equals to C1, which is equal to what? X. Alternate what? Angles. AD parallel to what? GC. GC, we're already done. We've proven that those angles. No, Tesmia, it's never an assumption. We're not assuming proportionality here. We're not assuming proportionality. Okay, can we then say that triangle ACB is an isosceles what? Triangle. Why? Two angles are equal. We okay? First question, good. So I want us to work together and get the answers. I don't want to be the one giving you answers. However, I'm going to help you in some places. Please talk to me. If this is X and this is X, is it okay to say this line and this line are equal? And sides. Oh, you are saying probability. It's not really an assumption. It's not an assumption. Okay. Can we, I want us to try, let's finish quickly in 10 minutes or so. No matter what, we must at least do question 1 of paper 1 and number patterns if we can push. I want to sort out inequalities. Is that okay? I want to sort out inequalities. Check this. Prove that what? BC over AC equals to BG over GA. BCAC. I'm going to recreate this diagram for you. What are we proving? BC over AC. And I want you to try. BC over what? AC equals to, did anybody get it? BG, you see, they said GA. BG over, don't come with your, where your GA is. All right? Want to try quickly? Let's think. BC, go and trace those lines. BC over what? AC equals to BG over GA. Oh my God. No, okay, there isn't the smaller triangle. Okay, Biggie says there isn't a smaller. Okay, let's use highlighters to make it blink. What are we looking for? We're looking for BC over what? AC equals to what? BG over what? GA. You think, okay. Anybody's in? I'm done. Yeah. It's okay. Look, let me give you a quick idea here. I made a symbol here to tell you that this and this are equal. When examiners, when you see a question like this, quickly find, do you notice they said BC over what? AC. They could have actually written it like this. BC, what is AC equal to? I want you to retrace this now. Let's retrace it. What are we looking for? BC over what? Equals to. There. So be careful of those equal lines. Once you see something playing around that equal line, write all the possible options that you can get. So examiner knows this is what the examiner is actually dealing with. But they are saying this and this are what? So they are diverting your attention away from this line, which is where the answer is. I don't know if you get what I'm saying. Already they took your attention. Biggie, they caught you. You were in this triangle. But we know this and that are equal. So take note of that when lines are equal, write all your possible options out. If they gave it to you like this, do you know that you will be done? Because proportionality with your parallel lines. Okay? So we are done actually. What will it be? So let's answer. Oh, I'll start answering from here. Prop what? Theorem. Remember, parallel lines. Which lines are parallel? GC and AD. GC and what? AD. But DC equals to AC. Sides, opposites equal what? And proof that it's isosceles earlier on. So now I am working with the sides. Therefore, BC, instead of writing DC, what do I write? AC equals to what? BG over GA. Proven. Did that make sense? So they try to divert your attention. That's why I said anything you find, make notes on. And this time around, do you notice you have question paper? Question? Lost Biggie? So what we used here was to use the fact that this we proved to be what? We said this is what? This was proven as what? An isosceles what? Triangle. Two sides are equal. Okay, Idris. Here is what the examiner said. Check this. Examiner wanted us to prove that BC over AC. BC over, let me use a black one. BC, BC over what? AC equals to BG. Now, do you see that here they went on one side of a triangle? But we said this line is the same as this line because it's an isosceles triangle. So I could change the whole question and say BC over DC, BG over GA. So I am working there. And I know that those are parallel lines. Hence, simple proportionality now. The only thing was they changed this line to that line. Talk to me, Idris. Did you get it? Hence I'm saying, guys, anytime you find something, write it on the diagram. Make notes of the inference or the conclusion. So immediately I said isosceles. I quickly interpreted what an isosceles triangle is. Opposite angles are equal, and I know that two sides are also what? Equal. Make sense? And that was actually what saved us now. All right. Look, these 3 marks. If you get these 3 marks, I'm going to beat you in the exam hall. Just see me appearing. Prove that AFG is similar to triangle what? ABC. You just see me appearing, smacking you in the head. Quack, 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 quack. Those 3 marks. What are we proving? Triangle what? AFG is similar to triangle what? ABC. I'm going to redraw this triangle again. Okay. Did you get a triangle? Triangle what? AFG. You sure, Biggie? How sure are you? AFG and ABC. Do you know how I did this last week? And you cannot, guys, this question is always there. What did I do last week, if you remember? No? Prove that they are similar. Nope. How do you, now guys, now you are getting things wrong. How do you prove that 2 triangles are similar? You guys, please put that note down. To prove similarity, you need 2 angles. Now. And I said to prove this, list the angles. Idris, prove 2 angles and you're done. Tanko. List the angle. So let's go to triangle AFG. Everybody. AFG. Which triangle are we looking at, by the way? We're looking at this right. I don't know if you see the right angle triangle. AFG, right? So this one is what? A, F, and G. You can label it to make life easy for you. A1, A2, F1, F2, G1, 2, and 3. So this is what? 2, 1, and 1. Make sense? So what do I have? 2, 1, and 1. Now, what about ABC? A, B, and what? C. I don't know if you see another right angle triangle. How does it look? Yep, like that. A, B, and what? C. You see that? What A is this? A2. What B is this? Which is 90, right? What C is this? 1 and 2. If you appreciate what I'm doing here, we are done with this. What is this? A2. What is that? B. C1 plus. Already, do you know I'm done here? What is that? Come on. We are not, when we prove similarity, we're not using side. We don't use sides. To prove similarity, there's only one way. Prove that 2 angles are equal. That's the only way to prove what? Similarity. Check the next one. What can you tell me about F1 and B? They're both equal to what? 90. 90 degrees. And what do you need? You only need to prove what? 2. Automatically, what are you going to tell me about the third one? Third angle. Oh, therefore, triangle what? AFG is similar to triangle what? ABC. What's your reason? Angle, angle. Guys, you are done with that question. List out your angles. First and the first, second and the second, third and the third, and get your answer. Guys, please don't forget, that's a very, there's no paper you are going, that's 3 marks that must be guaranteed for you. There is no paper you are going to look through that will not have that question. And then I told you, immediately after proving your similarity, what do? Write your ratios. I am not even checking the next question. I don't know whether I'm going to, just going to write it somewhere. It's my ratio. AF over what? AB, AG over AC, FG. I don't know if I'm going to use it, but just write it down. You have not committed any crime by writing that down. You haven't done anything wrong. Can I go to the next questions we have? Let me do this. Let's cut it out. Let's cut it out. All right. Let's check. This is what we have. Let me do this. Let me try something. There's something I want to try in my head. If it's going to work. Okay, we know it's 3 marks, 3 marks, 2 marks, right? Let's write the mark allocation here. 3 marks, 3 marks. All right, it says, I want to just reduce this and cut. We know it's the length, right? Calculate the length of whatever it is. Okay. This is what I want to do to make all these things on one page. And then, yeah. Lovely. Beautiful. Meanwhile, don't forget that ratio that we have, right? Check the first question. If BC is now 12 units, let's go to our question and write the 12 units. So you see there's so many things you are writing, so write neatly on your diagram. And the radius of the circle is 10. Okay? Radius of the circle. I'm going to say something. Can I say my AC is 20? Because we are told it's a diameter. Okay. Calculate the length of what? AB. Is this a matric paper? Amen. Then, the 90 degrees already tell you it's a rat. What do you do when you see a rat? Theorem of Pythagoras or trig what? Ratio, SOHCAHTOA. I don't know if you see my triangle already. That's what I have. It looks like this. This is A, this is B, and this is C. This is what? 20. This is 12. That is, please get me AB. I don't want to even do this. Me doing this is an abuse to a maths teacher. Quickly, if I do this now, it's an abuse. You are abusing me. And I refuse to be abused. Teacher-based violence. TBV. Okay. I have 3 answers already. Bibi, what's your answer? 16, wrong. Wrong. 16 is wrong. 16 units. She almost had a heart attack. She almost had a heart attack. All right. So AC squared equals to what? AB squared plus BC squared. But please write the theorem. Remember, it's Euclidean. Pythagoras. AC is what? 20 squared. We don't know AB, but we know BC as what? 12 squared. So you said 16, right? 16 what? Units. Done. Let's go get GF. 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 Yeah. It's in the middle of nowhere. Huh? Yeah. I'm glad you said there's no, because somebody would have made an assumption that somewhere there's a radius. Okay. This looks interesting. GF. Where's my thinking pen? All right. We are looking for GF. What can we do? If you see anything, please let us know. The only thing I know now, okay, that this is another right angle, but see, the examiner wants you to say that this is 10. And that's where there's going to be a big problem. Okay? Yes, teacher-based violence. All right, let's see. How do we get FG quickly? Time is running out. FG. We know that as 20. Oh, wait. FG. We know this as, which lines are parallel again? This one, right? Okay, this is literally in the middle of nowhere. Which other angle do we know? Okay, let's check something. If we can get this angle, will it help us? And you know what's annoying? Oh, it's 3 marks. Okay. It's annoying because it's 3 marks. We're looking for F. Oh, no, I'm cleaning. We're looking for FG. I'm thinking, okay, this angle we can get by using trig ratio. But will that really help us? Is there something we are missing? Blah, blah, blah. Okay, let me write. Let me just, if anybody sees anything, let's walk through. Yep. AB, that is half. Yes. Line CG bisects that angle C. So remember we had said this is what? X. And this is what? X. Okay. No, we cannot make that assumption as well. No. Okay. What I can say, wait, I'm seeing something. I don't know. Okay, let me think through first. I saw something. Let me just think through first. That there is a circle there. Let me see if it's going to work. Such that AG is a diameter. But will that help us? No, we can. We can. So we can just end the circle. No, because remember, angle F there is 90 degrees. So it makes AG a diameter of a circle passing through AFG. Okay. I'm trying to see what are. But wait, hold on. Wait. What are we looking for again? We are looking for GF. Let's check something. Don't we have GF here? Check. We do. Okay, let's go. What else do we know? Let's see. What dimensions do we know? Do we know AF? No, we don't. Do we know AB? Yes. We know AB, right? Lovely. Do we know AG? No. Do we know GAC? Yes. Right? Do we know BC? Yes. What are we looking for again? FG, right? Let me do this. Let me do this quickly. Okay, if you check, what our AB again? AB, 16. Okay, is there a way of two combinations that we know? Somebody says, isn't AG 8? Mary, what would be your reason? I want us to have reasons for saying something is 8. I need us to be careful about making assumptions. What would be your reason for saying it's half? But you know what I can do is, okay, wait, guys. I can actually get AG and wait, okay, check my ratios, right? What is missing? What will help me? If I get AG, then I can work out FG. Okay, spell your saying? Yeah? BC over AC is equal to BG over GA. Yeah, that's what I was saying that, okay, I was also looking at that. BC over what? AC equals to what? BG over what? GA. That's why I'm saying that if I look at this combination, the only thing stopping me now is what? If I can, then I can cross multiply. And so let's see. Is AG possible to get? What is my BC? 12. What is my AC? 20. We are looking for BG. Do we know BG? BG we don't know. Do we know GA? We don't know GA, right? Yeah, I'm trying to work out a ratio, okay? If we are able to work out what AG is, which we can now, all right, I see where we can get to. Okay. So you see that ratio came back to help us when we wrote it down. And all I'm doing is checking what I have. So if we can get AG, then we'll be done. Okay. So our aim is to get what? AG. Mind you, Okay, sorry guys, I was just changing my mic. It's not like we continued class. So, watch this. If I look at this whole triangle, what is missing is AG. Do we agree? Are you there with me? We said if we can get AG, then we can work out that one. Can I use my proportionality theorem? I don't know this length, but I know the whole thing. Does that make sense to you? Are we together? I lost you? AG, which I don't know, over what? The whole length. What is it? AB. Do we agree? Equals to. I know this, which is going to be what? DC over the whole length. DB. Do we agree? Prop what? Theorem. Which lines are parallel? AD parallel to what? GC. Does that make sense to you? I don't know this. This over that. This over that. Do you see I know all the other ones? AG, what I don't know, over the whole length. That's the top over the whole length. The top over the whole length. Proportionality what? Theorem. So, AG, what is my AB? 16. Do I know DC? 20. Do I know DB? 32. AG is 10. Just use ratios. AG is. So do you see those of you that were saying AG is 8, making assumptions? Baby, I knew in your heart you were saying AG is 8 units. Now, do you think we can now walk through? Now we know that what? AG over what? AC equals to FG. There may be a shorter way. 8 over, what's our AC? 20. What's our FG? We don't know. What's our BC? 12. Oh, game over. What is FG? Are you sure? 24 over 5. Interesting question. No, Idris, do you see that Mary was saying it's 8 units? Do you see that it's not 8 units? And I've proven that it's not 8. It was easy to make. The examiner actually wants to lead everyone to make that, especially when you are stuck. AG is 10. Yeah. Oh. BB, it's you. Thank you for bringing that. I think the 8 was, yeah. So AG is, and I did mention 10, right? 10 over 20, that would then be equal to what? 6, right? 6. Yes, your question, please. Yeah. You can. What did you say? What is 16 times 20? Do you even calculate? 320. Why 36? Okay. All right, thanks. I saw it now. It was the 8, and BB is here, busy shouting 8, 8, 8, 8, 8. All right, but I'm glad that we see that we cannot just make assumptions, and you see. The last one is very easy. I've seen the last one. Thank you. We use the same ratio here. I'm looking for AF. Do we know A? Do we know A? Yes. Do we know AG? Done. That's why, do you see the importance of writing out your ratio when you write your similarity? The questions that follow will have something to do with it. AB equals to, but let's write a reason for this. What is it? We are saying triangle what? We proved one similarity. AFG is what? Similar to triangle ABC. You must write that as well. That's your reason. So AF, do we know AB? 16. Do we know AG? 6. Do we know AC? 20. So what is AF? 24 over 5 units. Thank you, guys. Are we okay? Did it make sense, guys? The main thing is to get our approach. And that's what we are learning. So take note of the things you have learned. How to prove similarity. You need 2 angles, but list those angles. Once you are done proving similarity, what do? Write your ratios. It will come in handy for you, right? Proportionality, what do? You need a triangle with 2 parallel what? Lines. Okay, so we will end our paper 2 here. Oh, we're done with the questions, right? Okay, beautiful. I hope we were able to help ourselves to remember those little concepts again. Okay. Just saving this file quickly. But I really enjoyed the session. I really enjoyed the thinking through. And once you learn those little secrets, you know what you are doing? You're saving time. So let's learn those little secrets